On this video, we're going to go over the second part of the circuit notes. So electric circuits are a set of electrical components joined together so they provide one or more complete paths for a current to flow through. Some basics with them is that we have an open or closed circuit. So a closed circuit is going to be where your pathway is continuous. There's no breaks, there's no openings in it. An open circuit is when your pathway has an opening or is disconnected in some way. So for instance, in these two diagrams, for A, we have an open circuit because right here is an opening. This symbol right here is a switch, and our switch is open. So if this right here is a light bulb, our light bulb would be off. So if you think like this light's off, the switch is off the wire, so it's an open circuit. And then for B, our light bulb is on because we have a closed circuit, so it's on the wire. So if the light's on, it's on the wire, it's a closed circuit, right? To show you the rest of the symbols that you'll see in these diagrams, for a wire you have a line, a resistor is a zigzag line like this, a light bulb is a circle with an X through it, a cell, which is a type of power source, is a long line and a short line drawn like this, and a battery is basically that symbol duplicated. And then a switch, just like we saw on the last slide, looks like this. This would be an open switch, and then a closed switch would look like that where it's touching the line, right? Now let's get into series and parallel circuits. You probably learned a little bit about these in middle school science, hopefully. But a series circuit is when your components form one single pathway. So if we start at our battery and go around, they're all going to just be one loop, right? Versus a parallel circuit, your components are connected to form more than one pathway. So we can start at our battery and go through this light, or we can start at our battery and bypass the first light and go through the second light, right? If you think of like Christmas lights, like if you take one light out and the rest go off, you're going to have a series circuit if the rest of them go out. Because if I remove a light bulb, it breaks that circuit. Versus a parallel, if I take out one light, the rest can stay on because it can bypass the break. Right? So with a series circuit, your equivalent resistance, which was that total resistance we talked about in the last video, will be greater than the individual resistances because you're going to just add up each of the resistances to find your equivalent resistance, and that's this formula here. So whatever the resistances are of each, in this case light bulb, you would just add up all of those, right? For the current in this circuit is going to be the same at throughout the circuit. So at each light bulb in this case, your current would be the same. And then the voltage will be different at each resistor. So that will change based on how much the resistance is of that circuit. And we're going to do a diagram in a moment, right? Or a example with a diagram in a moment, right? For a parallel circuit, your equivalent resistance will be less than the smallest resistance in the group, because you're going to use an inverse formula, which is this one, and we'll do this again in a second with a example. But it's the inverse of each of the resistance given to you for how many ever you've got, and then you take the inverse of that total. The most common mistake I see with this formula is not doing this -1 right here, so don't forget that one. Your current will be different through each branch of the circuit. So like this would be a branch, this would be a branch, and the current would be different here based on what the resistances are. And then your voltage will be the same through each. So this one and this one will have the same voltage. So these are opposites. So for series, your current's the same, and then for parallel, your voltage is the same. So make sure you remember that. It's a tricky thing to remember when it comes time to quizzes and tests. So get that down quickly and it'll make this a lot easier. Right. So let's go on to an example. The first one is a series circuit. All right. So we're going to solve for the voltage and the current at each resistor, and we're going to determine the total current and voltage in the circuit. And you're going to see commonly like charts like this because it's easy to set up, and then we have our diagram right here. So in this case, we do have a series circuit. We can check that by knowing that there's just one loop going around. Right. We're given the resistance of our 3 resistors, and we're given the equivalent, the total voltage, right? So the easiest place for us to start in this case would be to go ahead and find the total resistance, or the equivalent resistance, in other words. So since we have a series circuit, we're going to use the series circuit formula, which we're just going to add each of them together. So we're going to add 10 plus 30, 10 plus 20 plus 30 together, and that gives us an equivalent resistance of 60 ohms. So I'm going to drag this 60 right there. Right, so that's our first step. Our second step we could go ahead and do would be go ahead and find the total current. So we're going to use Ohm's law to do this. We have our total voltage of 6, and we're going to plug in that total resistance we've got. So this whole row, bottom row here, is going to go together. So this is Ohm's law. We plug in the 6, we plug in the 60, and we get 0.1 for that total current. So I'm going to drag that up. All right. Now with a series circuit, we need to determine which of these stays the same. Does voltage stay the same or does current stay the same? All right, so going back to the previous slide, we know that in a series circuit, the current stays the same. So we're going to make the current all 0.1 here, right? Because that's what stays the same, right? So then we can go ahead and find our voltage at each spot, since we now know the current is all 0.1. So we're going to use Ohm's law again for this, and now plug in the current for the first one and the resistance for the first one, and do that for each of these. So this is shown here. So you just multiply them, so you end up getting 1, 2, and 3. So it's pretty easy numbers to work with. So the voltage for the first one is 1, the voltage for the second one is 2, and for the last one is 3. So that makes it really easy. And then we've solved for everything we need, right? So let me move on to a parallel circuit. All right, so now we're going to solve for the same stuff. We actually have some of the similar numbers to work with, but now we've got a parallel circuit. So you can check that it's parallel because you can see there's multiple paths for the current to flow through, right? We are going to do similar steps here, but this time, since we have a parallel circuit, we're going to use that formula to solve for our equivalent resistance, which is that inverse formula, right? So we're going to plug in 10 to the negative 1 plus 20 to the negative 1 plus 30 to the negative 1, and then take to the negative 1 of all of that. When we do that, we get 5.45 ohms, right? So that is our equivalent resistance or total resistance, okay? Then the next step is going to be to use Ohm's law. We can go ahead and find our total current. So we're going to plug in that voltage and that resistance we just found, and we divide 6 by 5.45, and that's going to give us 1.1 for our current, or our total current, right? From here, we want to say, okay, is our voltage the same or is our current the same? So going back to that previous slide, we know in a parallel circuit, our voltage is the same through each branch, right? So we want to put that 6 voltage is going to be the same. All right, and the last one. There we go. So that's the same, and now we can solve for the current at each resistor. So we're going to use Ohm's law again. We're going to plug in that 6 volts for each of them. We're going to solve for I in them, and then we're going to plug in the resistance. So the first one would be 6 divided by 10 would give us that 0.6. 6 divided by 20 gives us 0.3, and then 6 divided by 30 gives us 0.2. So those are going to be the currents at each resistor in our circuit, right? So we will keep practicing this and get you good at it before we take any quizzes or tests. But please let me know if you guys need any help with this.